Hey everybody, we're going to do our power, energy, and cost notes. You know, your parents complain about the power bill. Let's figure out why. So, first of all, definition. Power, the rate at which work or energy is used. My calculus people, that is a dW dt. Now, electrical power is not any different than regular power. Power like going upstairs or lifting things. It's the same, but it's in electricity, it's a little different calculation. So the most common used one, although not always, is power is voltage times current. When you substitute Ohm's law in here, using R equals V over I, we can come up with two other versions of the formula. Now, just to make it simpler, we're going to put these in the circle formulas, okay? So one of them will look like this. This just makes life a little, so you put the P, the V, and the I. The second one, we're going to have P, I squared, R. And then the third one, it's V squared, P, and R. Remember, if you cover up the one you're solving for, if they're on top and bottom, you divide. If you cover up the top, then you're multiplying. It's just a quick way to not have to worry about how to do these formulas. So just keep those handy. So, power is measured in watts. Let's talk about some electrical powers, okay? So I'm gonna diverge for a second and show you the bottom of my electric toothbrush. And notice right there, 2 watts. It uses 4.05 volts and 2 watts. So my electric toothbrush uses 2 watts. So I bought these fancy bulbs. Let me see what they look like. They're very fancy. Super bright LED bulbs for the kitchen because I can't see a darn thing. I wonder how much power they use. Well, let's see. Here's the, oh, there it is. They're low power. You can see right there, 15 watts. Super bright. I love them. They make so I can actually see. Maybe you go to the store and you buy light bulbs. Well, this is supposed to be a replacement for a 100-watt bulb. 100-watt bulb's pretty bright and it's expensive, but these LEDs now only use 15.5 watts, a huge energy savings. So if you can lower the wattage, okay. This one's a little tricky to see, but you know, it's a blow dryer. I'm going to zoom in a little bit. And blow dryers are bad for power. They use up a lot. I'm going to try and zoom and see if you can see right there. 1,875 watts. This is why when you use these, you can see it's 125 volts AC, 60 hertz. We'll get into all of these, but there's the power rating. Anything that uses heat, it's going to use a lot of power. And if you use it for a long time, it's going to also eat up a lot of money. So let's go in. So you can look at a lot of your electrical appliances. I just picked some small things so that you could see them. All right, so let's do some practice problems. Have a calculator handy, and maybe we can just use the little circles today to make life a little easier. All right, first example. I have a 75-watt bulb, and it's connected to 120 volts. Okay, power, 75 watts. Voltage is 120 volts. What is the current in the lamp? That means I need I. All right, so if I use this circle, I have P and V, and I need I. If I cover up I, it's just P divided by V. So 75, put this in here, 75 divided by 120 gives me 0.625. We'll call it 0.63 amps. All right, what is the resistance of the bulb? Well, I'm going to stick to using 75 and 120, keeping that I have voltage and power. Let's see which one of these would work. Well, I have voltage and power, and I want to find resistance. So if I cover this up, I'm going to do V squared, which is 120 squared, divided by the power, 75. So, see how shortcut they are? All right, so 120 squared divided by 75, I get 192 ohms. So 192 ohms. Yeah, I know, my omega's not the greatest. So any three of these can be used. they all get used probably equally as much. Maybe I use this one more and that one second and maybe that one third. I don't know. All right, let's talk about energy. Oh, by the way, the power company doesn't actually charge you for power because you can see there's no time here. You have to use it for a certain amount of time, like a month. They charge you every month. Power company actually charges you for energy, and there's a new unit that they use, which we're going to introduce. All right, so energy is the power, which is like what I showed you on those appliances, times the time. The longer you use it, the more expensive and the more energy, and of course the higher the power. So there's two units. Energy is typically in joules, which in this case is watts times seconds when you do power times time. But the power company doesn't want to be charging you for billions of joules because it's a lot of energy we use. So they have created a different unit called a kilowatt hour. We're going to go over some bills and you're going to see this on my bills. And then the power will either be in watts or kilowatts. So if you're going to use joules, you have to use watts and seconds. If you're going to use kilowatt hours, you must use kilowatts and hours. So there's kind of some choices here. All right, so let's put this to work. A 15 ohm heater, so R is 15 ohms, operates on a 120, which is pretty much what we have in our houses, except for your dryer and your oven. What is the current? Okay, so this is not anything except Ohm's law, okay? So we know R equals V over I, so 15 equals 120 over I. So let's solve for this. How much current are we going to get? So it's going to be 120 divided by 15. It's going to be 8 amps. That's a lot of current. How much energy is used in this heater in 30 seconds? Well, energy is power times time. Well, I don't have the power, but I do know that I can use volts times amps to substitute for that. So I'm going to just substitute V times I times the T. All right, so the volts were 120. The amps we just found were 8, and it's 30 seconds. All right, so 120 times 8 times 30 gets us 28,800 joules. I never converted anything into kilowatts and hours. I left it in. These here is watts, and these are seconds. That's what makes up a joule. The next one, I'll apply it. All right, so what does it cost? Well, you're going to figure out in a little bit what we actually are getting charged. I haven't even checked it this year, so we'll get a new. Basically, it's just like, this isn't really a fancy formula. It's just like if you buy 10 cans of peas at $1, it's going to cost you $10. So the cost is going to be the energy times the price. And of course, our answer will be in dollars. For these, you have to use kilowatt hours, so you can't be in joules. And you have to know the power company's price per kilowatt hour. In this example, I'm using 12 cents. Okay, so I have a space heater. We only use those sometimes in the winter. Uses 15 amps, so I is 15 amps from 120 volt source, so that's our volts, which is common for a heater in our houses. Now its time is 5 hours per day. So the first thing is how much power? Well, this is easy. We can just do the P equals VI. So that's going to be 15 times 120. So 15 times 120, 1,800, you can see that, watts. Now, since this is going to be a cost problem, I need this to be in kilowatts. So I'm going to divide by my 1,000 and get 1.8 kilowatts. How much energy in kilowatt hours does it use in 30 days? Okay, well, now I'm going to use energy equals power times time. The 1.8 kilowatts is the power. And the time, well, I'm using it 30 days at 5 hours a day. So 30 times 5 is going to be 150 hours. Okay, so 1.8 times 150, get 270 kilowatt hours. And it's not per hours. Some people use a dot, some use a hyphen, some don't even put anything there, but it's kilowatt hours. Sorry, I'm hitting my camera, so it's making your thing shake. My bad. All right, so the last one, this is how we do the cost. At 12 cents per kilowatt hour, how much does it cost to run the heater? Well, it's cost equals energy times price. So it's 270 times 12 cents. All right, so I'm just gonna hit times 0.12, and I get $32.40. So when it's a money, write it out just like money. And that's it. So we're going to talk a bit after these notes, and I'm going to go through some bills and talk about all the problems that can happen when you use too much energy. All right, there you go. Peace.